Hi, welcome back to Moose in Chemistry. This is Electron Configuration of Strontium SR lesson. Strontium is the 38th element on the periodic table. So we're going to write 38 right here for our atomic number. And its atomic mass number is going to be 88. Well, since the atomic number is 38, we have 38 protons, we have 38 electrons. But what about our neutrons? Well, to do neutrons is pretty easy. Just go AMU minus protons, right, equals the number of neutrons. So we would go, of course, 88 minus 38 equals 50 neutrons. So we're going to put a 50 right there. Pretty darn snarly, huh? All right, let's go ahead and clear some space out there for ourselves. Let's take care of this real quickly. Excellent. All right, now, let's look at our electron configuration. But before we do, remember that the S subshell can hold 2 electrons, the P subshell can hold 6 electrons, the D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. We're going to use the off-ball principle, which clearly states that you fill the lower shells first, and we're going to use the diagonal rule to show this. Here's our diagonal rule right here. So let's get started, okay? So 1s2. 1s2. Wow. 2s2. Pretty snarly, huh? Looks easy. You know what? It is. 2p6, 3s2. See how that goes? Can't mess up if you just follow that rule. 3p6, 4s2. You just keep going until you run out of electrons. 3d10, right, 4p6, and then 5s2. So 3d10, 4p6, and 5s2. Hey, look, you're done with that. Wasn't that easy? All right, let's look at orbital notation. Orbital notation uses Hund's rule. Hund's rule says that you have to fill every suborbit first with an up arrow, and then in that particular orbit, and then with the down arrow. So let's look at 1s. Watch this. 1, 2, there you go, look at that. 2s. Ha, amazing. 2px, 2py, 2pz. Here's a good illustration of Hund's rule. 1, 2, 3. See, every suborbit is filled now. Now put the down arrows. See that? Wow. Pretty darn snarly. Okay, let's just keep on going with these guys here. It's all filled in. No, I tell you, doing electron configuration and orbital notation, double gas notation, quantum numbers, I mean, it's a lot of fun. You guys can have fun with your friends with this. Oh, come on, you know your friends will like doing this with you. Come on, let's just have some fun with this. It's just darn snarly, isn't it? Look how easy this is. Just so effortless. 4px, 4py, 4pz. Okay. And then 5s. Now we have 2 left, so 1 goes up, the other one goes down. That's it for orbital notation. You thought it was going to be hard. Let's look at a noble gas notation. Well, the nearest noble gas, the strontium, is Kr, which is krypton, right? So let's go ahead and put the Kr in there. And then we're going to get our valence shell right here. Wow. So we're just going to write 5s2. That wasn't hard. No, of course not. Now, when you look on the periodic table, the principal quantum number is in 5. It's 5. It's in the fifth period. Pretty cool. The angular momentum number is going to be 0 because it's in the S block. Yep. Strontium is like the second element over in the S block right there. So there you go, huh? The magnetic number then is, of course, going to be 0 also. Man, this gets really easy. Well, let's look at this last arrow right here. It's going down, so it's going to be 1/2 negative. And that takes care of Pauli's exclusionary principle, which says no 2 elements can have the same set of quantum numbers. Well, that's it, guys. You be snarly, and we'll see you back here at Moose in Chemistry.